This is Robert, and the amplifier is together, and I'm a short way into the long, tedious process of biasing up the amplifier. And it's a balancing act, as I mentioned before. And what you're looking at here are 3 meters, and I wish I could have gotten another one of these guys, but they're getting rare and expensive these days. So I got this poor sad thing. It looks like the previous owner was teething on it, but what I'm doing now is slowly cranking up the bias pots and seeing what I get. This is positive bias, negative bias, or N channel, P channel, and this is the output offset voltage. And they all do a little dance, I'm discovering. It's a little nerve-wracking. Okay, also, it's good for you to get a nice tweaking tool. It can save you some misery. If you don't have one, you can just take a wooden stick type Q-tip and carve it into a little screwdriver end. But you want to have something that's non-conductive, just in case you drop it into the guts of your amplifier. You don't want it to cause a major catastrophe. If all you have is a regular small screwdriver, I strongly recommend that you wrap any exposed metal on it with electrical tape. Make it and then just keep the adjustment area just a slight bit of it peeking out to where you can use it. This is a standard pot tweaker, which I don't know how well it comes out, but there's a screwdriver tip that's recessed into a tube, and it's nice because it gives you a secure fit over the potentiometer. But what I'm going to do is start tweaking the pots. These are P1 and P2 on the front end board, and P1 affects the P channel and P2 affects the N channel side. In spite of having about a kilowatt of LED lights over my head, I'm still working in a shadow more or less. But anyway, what you'll find too is P1 and P2 turn in opposite directions to increase the bias. Oh wait, I've got them backwards. So yeah, P2 is on the left. It turns clockwise, and P2 is adjusting negative. P1 is adjusting positive. It turns counterclockwise, at least the way I have my board oriented. And in this case, I have the power supply connections at the top, speaker connections at the bottom, also the input pairs at the bottom. So depending on how you have these oriented, it could be different. So let's see, I'm now on P2, negative side, and I'm going to crank it up, and if you notice, the small meter is moving up. But if you'll notice, it's also affecting not only the big meter, but the offset as well. So I'm going to take this up to 30. And when they describe, you notice the offset's now at about 70. When they describe the process initially in the builder's guide, the initial description just has turn up P2. I adjusted P2 up. This is P1. I'm going to turn it counterclockwise. And I could do one or two things. I can try and get this to go up or get the offset to go down. I'm just going to adjust it for the offset to go down. and you see that as it climbs, the little meter climbs up, the offset goes down. But it's also slightly making a change to the big meter as well. So this is where it gets to be kind of a balancing act here. So, oh, this thing keeps wanting to fall asleep. All right, so we're now more or less back in stasis again. So we have our plus 41 here, millivolts on, that would be P1. We have minus 37 on P2, offset is nice and low. So what I've been doing is cranking it up a few millivolts at a time, and then I'm going in and seeing if anything gets hot. So I'm looking at the 4 power MOSFETs mainly. And I'm doing that with this guy, which is a Fluke, what do they call these things? 59 Max Plus IR thermometer. But you can find variations on this at a lot of places. So far nothing's getting significantly hot, but then I'm at, they recommend bringing this up to 300 millivolts, which I'm a long way from. But I want to do it in small steps, just in case something wants to misbehave. It might give me a chance to kill the power. What am I on now? This should be P2. It turns clockwise, so we should see it on this guy. And there we go, 39. So let's bring it up to 45. Going to get a huge amount of offset on this thing, just in case. There, we're at 45. So now I'm on P1. It goes counterclockwise, but I'm not even going to look at the big meter. I'm going to look at the offset and just crank the offset back down to 0. It seems like I'm always a little bit higher on the plus side here. So, oops, overshot. So let's go back. There's a fair amount of slop in this potentiometer too. Even though it's a nice Borns, it does have a bit of slop to it. Okay, so yeah, there's what? We got about 4 millivolts difference between the two. I'm not gonna, that I'd say is a minor issue, but this kind of how it goes. I've been just slowly bringing them up. I've got the thermistors glued down, and they now have duct tape over them for the moment, just till the glue dries. I used, what is it called, E6000, which is like a heavy-duty silicone RTV type glue. It's non-conductive, and it deals well with high temperatures. It's a little tougher strength-wise than silicone seal. It's more or less equivalent to shoe goo, as I understand. But I got that done and mounted the capacitor boards on the front panel, and then tried to get the front panel back on with the bottom plate on. I'd put the bottom plate on the amp, and sure enough, it wouldn't go on. I could get 3 screws, but that 4th screw just wouldn't line up. And so I did, with much cursing, I had to take the bottom plate off and loosen up the mounting screws for the heat sinks on that side, so I could kind of juggle, wiggle everything around to get it the clearance I needed to get that fourth screw in, and it is very tight. I mean, there's not much room in the corners of this front panel. The top two screws aren't bad. The bottom two are a nightmare. One screwdriver was too long to actually fit in there without interfering with the speaker out wires. The other screwdriver would catch on that the nut I have that mounts the perforated chassis plate on the unit. So things look pretty stable. They say to watch for drift, but I don't think it's getting hot enough to start drifting. Well, we are slightly warmer. We've gone from 24 degrees C up to 25 degrees C. So, well, we might actually be slightly warmer than room temp now. But at this point, I do not have either the Variac or the dim bulb tester in the circuit. I'm hoping that will work okay. You don't want to... Yeah, I'm well past my initial turn-on tests and measurements where I had concerns whether something was just going to explode. Nothing so far is acting up. Okay, so I'm now on P2, turning it clockwise, and we should start seeing the little meter increase. I'm going to bring it up. Let's take it to 65. The big one's getting there before the little one. Come on. There we go. Okay. So now over to P1. The problem with the shielded tip is that it's hard to see what orientation it's in. Words to the wise, get the front panel on before you put the bottom plate with the feet on. If you're using the DIY Audio Galaxy 5 case for your project. There is some slop, there we go, some slop and wiggle room you have to be concerned about. Okay, so this turns, I'm on P1 turning counterclockwise, so we should see the big meter start climbing up. We should see the offset, there we go, the offset on the output decreasing. If we hear a bang, I will shut the camera off because I don't want you all to hear me cry. So far, knock on dining room table, it is being fairly well behaved. The little meter, it wants to shut off again. I have to keep juggling it. Fortunately, the default on this one is DC. Unfortunately, the default on the little Fluke is AC. So if it wants to shut off, I have to make sure to toggle it back to DC. There we go. Okay. So we're still seeing a fair divergence in the two readings. I'm hoping that's within the realm of normality. Let's see. What do we got? Yeah, we are slowly creeping up. I'm measuring 26C on the output devices now, on the power MOS. There. Okay, so we're on P2 again, turning clockwise. So let's see if we can. Oh, it went up to 80 pretty easy. So let's try 90. What do you think? I just don't want to see the offset start taking off, but it's really not. Uh-oh, what happened? Looks like it went to sleep. Yeah, see, we're back on AC. Have to hit that. Now there's 90. Okay. And we're getting a bit of a offset there. All right, so we're on P1 again, going counterclockwise, and we'll bring the offset down. Isn't this exciting? Yeah, I know. This is what you guys tune in for, watching meters go up and down. It's the fast-paced, action-filled world of professional Class A tweaking. Come on, keep going. There, okay. Whoa, and we're over 100 millivolts on each side now. You can have a significant difference in the bias as long as the DC offset on the output of the amp is at 0. That's more important than having these numbers match exactly. This is the important one. Again, it's getting that balancing act. I can't say I'm feeling any major warmth on the heat sinks. They're not cool, but they're more or less room temp still. This is the new toy. You've been looking at it for a while. I haven't said anything about it. It's a Siglent 200 meg, 2-channel. Got it fairly decent price on it. I got it a package deal with this signal generator, which I'm a little disappointed in. I mean, it has a pretty display if I turn it on, but the distortion on its output, I mean, it's rated like 1%. They're not even giving you any meaningful spec. So I did find this guy. This is a Tenma audio generator. This doesn't have a display, but it does have a better distortion spec, 0.05 through most of the range. So back to, no, this is P2. What am I saying? Turning clockwise. And let's see, there's 120. Let's go 125. There. Okay. Offset's a bit on the high side. Okay. P1 now, counterclockwise. Bring the offset back down. Now I'm following the instructions that are set forward in the building guides that 6L6 and other smart folks on the DIY audio site have set up. Very helpful. I'm trying to combine the two techniques here. do kind of like, where am I at here? Did I overshoot? I overshot, didn't I? And that wants to fall asleep again. Whoops, oh, there it goes. You think you'd know there's a signal on it. See, there it goes. So we'll just turn it back on. There. Okay. So we have a 9 millivolt difference between the two rails. There might be a little bit of heat there now. 28, 29, 28, 27. But this is basically how you do it. You creep it up nice and easy. You want to make sure once the devices get hot and start heating up the heat sink, then you have to kind of watch things, because you may find that you're actually having to back off on the bias. There may be too much. And that is one thing I am concerned about. That's why I've been kind of watching them, doing it in little bits and seeing how it settles. Right now we're solidly in Class A-B land. This would probably conduct if I hooked it up. I don't want to get too much going at once. So my printer broke down, so I had to hand copy all the bias instructions from the DIY audio website. And I do recommend that you make yourself a nice little diagram that shows where the pots are, where the test points are on the boards. Initially, you want to make sure, you also want to adjust the pots to make sure they're at 0 ohms across these test points initially. So P2 has TP1, TP2, P1 has TP3, TP4. Adjust those for 0 ohms with the amplifier off before you do anything else. So left side is P, right side is N. So P2 I've been adjusting and looking at the voltage across the test points TP2 and 3, which are basically measuring across one of the source resistors. Same over here. So everything looks reasonable. Still can't say I'm feeling any heat as such. So we'll go back and tweak it up again. Okay, we are on P2, turning clockwise. They were in the builder's guide, they recommend that you write on the top of the pots which direction increases them. It's a little hard for me to do that now that they're installed in the amp. And I thought about maybe putting a dot on whichever side goes plus, but I'm finding I'm not getting too terribly confused going with my diagram. Unless I try and talk about it, then apparently I get totally mixed up. But anyway, right now I'm on P2 again, adjusting negative on the P channels. So we'll be looking at the little scope again. And let's go for what, 160? There's 160. I'm feeling a fair amount of relief here that I'm not seeing the offset plunging to one side or the other as we bias this up. I mean, it's being very well behaved. So now I'm on P1, going counterclockwise, bringing that offset down. It's like like watching paint dry, isn't it? All the thrills and excitement of professional meter tweaking. Okay, so we're almost at 190 here. So this next round, why don't we shoot for 200? Oh, let's do a temp test. 29, 31. Oh, we're starting to get warm. 30. 29. Do I feel it? Not really. So again, we're on P2 counterclockwise, looking at the little meter. We're going for the big negative 200. Hopefully this isn't too big a jump. We'll see. The offset's still manageable. On P1 counterclockwise, we'll bring that offset down. Oh, it jumped up, didn't it? Okay, it's about 1 a.m. in the morning. The amp's been on about 5 or 6 hours, and I've been slowly trying to tweak it in here, and it's a bit maddening because you know, it'll drift up or down, and you have to pull the cover off to tweak it, and the minute you do, it loses its thermal equilibrium, and you're kind of having to work on memory of how it, what its previous settings were, and so you're kind of you're aiming at a moving target here, and basically what I've been trying to do is to get it to where I'm up near 350 millivolts, pardon me, on the source resistors, and trying to get the offset. I was hoping within 1 millivolt, but it looks like it's going to be within 2 at least. It tends to wander up and down a bit. But it's just a very time-consuming task dialing this thing in. Right now the heat sinks are at about 45 degrees C, which is warm, but not so warm that I can't keep my hand on them. I mean, they're fairly stable that way. But it seems to be more the internal temperature of the components that's affecting the drift. Oh, there it went above 2 a bit, and then it's slowly, no, it seems stable. Oh, crap. This means I may, no, now it goes back down. I know it's slowly working its way back up to 2, so I may have to tweak it once again. This is the maddening, time-consuming thing about this. And then it's horrifying when you first turn it on because the offset's way up at like 70, 80 millivolts until everything warms up again. Yeah, this is drifting now. I'm so tired. So it looks like this will continue tomorrow. And, oh look, now it's gone back down. It's toying with me. Don't mind me, I'm giddy here from lack of sleep. But, yeah, look at that. I mean, it goes up and down. Part of this may be that the heater kicked on. I wonder if the additional heat from the heater's making it change. Let's back up at 2. This channel, the left channel, seems to be quite enamored of somewhere in the 2 millivolt range. I've been trying to get it to come down closer, but it just seems to want to drift right back up there. And I've tried 2 techniques. Since it's a little positive, I've tried increasing the increasing the P channel bias to bring it negative. I've also tried decreasing the N channel bias to bring it negative. And neither one seems to be much more effective than the other. It still wants to drift up to 2. And I don't know, this may be perfectly fine. I doubt whether 2 millivolts is going to give me a significant turn-on thump. See, look, it's going back down. Okay. I think it's just going to toy with me. I notice it's not going down as low as it was before. It seems to be more comfortable around that 2 millivolt point. So I don't know whether I'm getting obsessive or what, but I may just shut it off and go to sleep right now. I literally did not think it would take, oh look, now it's back down to 1.5. Stop toying with me. Well, at least it's kind of more or less stable around the high ones. We're looking at the center one here, of course. This is the P channel supply, N channel. I shouldn't say supply, but the source resistor drop. And if we look at our heat sink, we're about 45, 6. No, went up a little. Yeah. The right channel's at about 44, 45. This channel's at about 45, 46, which is good. It's nothing tremendously hot. I'm not sure. They shouldn't get, since the current is more or less fixed, would they change under load? That I need to see. Of course, in a Class AB amp, they would, but I don't know about a Class A amp. And we're back up at 2. Oh, this fell asleep. Yeah, see, it seems happier up at 2. I doubt it'll swing back down again. I said I doubt it'll swing back down again. Yeah, it looks like I can't tempt fate. Yeah, see, it's getting higher now. So. I think I'm going to just shut it off and call it a night. Start round 3 tomorrow night. Problem is it's very time consuming because you got to let it heat up for 4 hours, do a tweak and wait 20 minutes or so to see if it stabilizes. Obviously, this last one hasn't. It's crept back up positive again. The right channel was a little easier because I actually got it to a point where I could tip it to trend positive or trend negative and managed to find a sweet spot in the middle. This one, no, it's gonna fight me. Yeah, see, we just keep getting higher. Yeah, it might even touch 3 if it wants. You also need to check the DIY audio website and just see what the other guys get on theirs. I mean, what is, am I killing myself trying to shoot for an ideal, or is there a practical range that's acceptable? Who knows, maybe anything under 5 is adequate. Solidly stable in the mid 2s now.